Hello, grade 7. This is Mrs. Lopez. We are in module 1, lesson 10 today, learning how to interpret graphs of proportional relationships. Okay, so there is nothing new really today. We are just learning how to read graphs and applying all the knowledge that we gained in the previous lessons. Example 1, Grandma's cookies. Grandma's special chocolate chip cookie recipe makes 4 dozen cookies. It calls for 3 cups of flour. Okay, create a table comparing the flour used to the number of cookies. Um, Also notice it says number of cookies and cups of flour. Number of cookies is not 4 because here we have 4 dozen cookies. Okay, so it is your choice really if you want to convert um, dozen cookies into the number of cookies. I would because later we are going to graph them and it just will make it um, probably easier, might not, but it really is up to you. I would just go and convert because it does say number of cookies, and that's what I'm gonna do. Since there are 4 dozen cookies and the dozen is 12, I will just multiply 4 by 12, and that will give me 48 cookies. 48 cookies I can make with 3 cups of flour. So 48 cookies with 3 cups of flour. Okay. Um, Is the number of cookies proportional to the amount of flour used? Explain why or why not. Um, it is, and we are going to find out. Well, we can, we can, because we always need to have 3 cups of flour or 48 cookies. If I divide, let's just go ahead and skip to the next question before we answer that one. The number of questions that are set up a little bit confusing here. What is the unit rate of cookies to flour? So that's where I need to divide cookies by the flour, right? Unit rate of cookies to flour. Cookies makes it a y since I'm dividing cookies by the flour. The number of cookies is going to be the y and the cups of flour is going to be the x. We are using formula K equals y divided by x to find the constants of proportionality or the unit rate, right? So we are dividing the number of cookies by the number of flour, y divided by x. 48 divided by 3. When I divide 48 by 3, I will get 48 divided by 3, I will get 16. And what does it mean in the context of the problem? We can make 16 cookies with 1 cup of flour. Okay, and I know it because I'm dividing cookies by the flour, right? Cookies by flour. So I'm getting cookies per flour. Number of cookies with 1 cup of flour. Okay, so I can make 16 cookies with 1 cup of flour. I can make 48 cookies with 3 cups of flour. I can make it right here. That makes a proportional relationship because 16 or 1 times 16 is going to be 16. In this case, our table is kind of reversed. Usually we would multiply by 16, right? So here we are dividing. So that makes it confusing a little bit. 3 times 16 will give us 48. So it's actually this way, right? So this number is going to be multiplied by 16. This number is going to be multiplied by 16. And this number is going to be multiplied by 16. So I can actually put 2 and 4 and 5 here if I want. So 2 times 16 will give us 32. 4 times 16 will give us 64. And 5 times 16 will give us 80. Okay. Now we need to model, so the relationship is proportional. The number of cookies is proportional to the amount of flour because the unit rate is constant. 16 cookies with 1 cup of flour because the unit rate is constant. 16 cookies with 1 cup of flour. Okay, now we need to model this relationship on the graph. So where will each one go? So here we have our x-axis. Here we have our y-axis. The label, we always need to have the title. So we have Grandma's Cookies here. On x-axis, since we have flour as an x, we will put the amount of flour, cups of flour. You can see that here. And on the y-axis, since we had number of cookies marked as y, we don't change that. So number of cookies. Okay. And all we need to do now is to graph this table that we had at the beginning onto the coordinate plane. Since we are working with high numbers, 48, 16, 32, 64, 80, I would count probably by 20, no, by 10, maybe even by 5. Let's make 5. And cups of flour by 1. So here we have our point 0, 0. For the relationship to be proportional, we need that point right here because we can't make cookies without flour, right? Cups of flour, we will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I can continue, but I don't have that much anyways. So we'll just leave it as that. With the number of cookies, let's count by 5. So we'll have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80. And I'm going to stop here because 80 is my highest number. Okay, so now we need to graph our table. So I can make 16 cookies with 1 cup of flour. So 1 cup of flour will give me 16 cookies, will be just above that 15 right here. I'm making a small dot. If I make a big dot, it's going to be not accurate because it's going to occupy a lot of space. With 2 cups of flour, I can make 32 cookies. So 2, 32, so somewhere here. With 3 cups of flour, I can make 48 cookies. 3 cups of flour, 48, so somewhere here. With 4, I will make 64. And with 5 cups, I will make 80. Okay, so now that I have my graph ready, I can go ahead and connect these dots because I can make more or less cookies, and any point that I will make, if I use proportional relationship and follow the recipe and directions and alter my recipe based on the ratios that I have, I will have good, every point here will be on the line. So this is proportional relationship. It's a straight line that starts from the origin all the points are on the line. Okay, so that last thing that we need to do in this problem is to write an equation to represent this relationship. So our equation is general equation is y equals kx. Now we need to see which one is y, which one is k, and which one is x. So on this graph, we can see that y is the number of cookies. Let's call it C for the cookies. C. Now we have equals. We follow this exact equation. K. What is our K? K is this number right here. This is our unit rate. 1 cup of flour is 16 cookies. So 16 is my unit rate. And we found it earlier by dividing the cookies by the flour. And x is the cups of flour. We can call it F for the flour. That is our equation. C equals 16F. And so I can use this equation by with if when I want to find the number of the amount of flour or the number of cookies without doing the table or graphing. So that makes it a lot easier. That's why equations exist. Okay, let's move on to the next one. And here we have another cookie, grandma's cookies. However, now we are going to work with sugar. Below is a graph modeling the amount of sugar required to make grandma's special chocolate chip cookies. So sugar is on the x-axis and cookies dozen in dozen. So here we have that dozen word on the y-axis. Okay, record the coordinates from the graph. So here I have several coordinates. I have 0, 0. I have 2, 3. I have 4, 6. I have 8 and 12. And I have 12, 18. And the last one here I have 16, 24. Okay. What do these ordered pairs represent? So we are looking at the graph and we are trying to find the connection. What do these ordered pairs mean in this context? So I will just pick 2 or 3, probably 3. So let's pick 4, 6. 4 is on the x-axis is the cups of sugar, and 6 is on the y-axis. It represents the dozen cookies. So we can say that we can make a dozen cookies with 4 cups of sugar. Okay. Again, the word dozen is important because if you put 4 cups of sugar for 6 cookies, it's going to be very, very sugary. 8, 12, we can make 12 dozen cookies with 8 cups of sugar. And let's do this one, 2, 3. We can make 3 dozen cookies with 2 cups of sugar. Okay. Grandma has 1 remaining cup of sugar. How many dozen cookies will she be able to make? Plot the point on the graph above. Okay, so how do I find how many cookies she can make with 1 cup of sugar? This is our unit rate. 1 cup of sugar is going to be right here, and the dozen cookies is going to be right here. I know it's going to be less than 5, and it's probably less than 2 because it's somewhere below that 2, but I can't really tell. And in math, we can't really guess. If I were to estimate, that's what you would do. But it's not estimation here. We can't guess. In math, there's no word for guess. Um, so we need to find the constant of proportionality. We need to find that unit rate of what they're looking for, because unit rate is how many dozen cookies you can make with 1 cup of sugar. And to find the unit rate, okay, I will divide y by the x. Y is my dozen cookies. Let's pick either point here and just do it. Let's pick 2 and 3 again. So we have 3 dozen cookies. I'm going to divide by 2 cups of sugar. And when I do that, I will see how many cookies will be done with 1 cup of sugar. 3 divided by 2 is 1 and 1/2. 1 and 1/2 dozen cookies I can make with 1 cup of sugar. Okay, last question here. How many dozen cookies can grandma make if she has no sugar? Can you plot this point on the graph? If so, where would be located? One thing I forgot to do is right here. This is our point. It's 1, 1.5. Okay, so this is our point right here that shows the unit rate. It shows how many dozen cookies we can make with 1 cup of sugar. Okay, and how many dozen cookies can grandma make if she has no sugar? On the graph, no sugar is 0. So if I multiply 0 by my unit rate, which is constant of proportionality, 1 and 1/2, I will still have a 0. So that 0.00 right here, it tells us that we cannot make any cookies without sugar. Um, of course, there are recipes right now that you can make very, very delicious cookies without sugar. However, in this recipe, following the proportional relationship, we cannot make cookies without sugar. Okay? Um, we plotted that point on the graph. We found it. 0 cookies or dozen cookies can be made with 0 cups of sugar. Okay. All right. Next exercise here. Your friend uses the equation c equals 50p to find the total cost for the number of people entering a local amusement park. So c equals 50p. C is the cost. P is the people. Complete the table to determine the total cost for groups of people entering the amusement park. So here we have number of people, 1, 4, 5, 9, and 12. And we need to use this formula to fill in the cost. Is the cost of admission proportional to the amount of people entering the amusement park? Yes, it is, because the unit rate, so again, we have y equals kx, right? And our equation is c equals 50p. The unit rate is the constant of proportionality. It's right here. We don't need to find it. It's given to us. It's right in the equation. The unit rate is 50. It means that the cost per person is $50. It might sound expensive, but we'll just go with it. Maybe they're buying like a admission ticket for as many rides as possible. So that can make the point, right? So one person can go with $50. Okay, so again, now it is important to understand that I'm multiplying 1 by 50. to make 50. That makes the number of people X, right? And Y is the cost. That's the Y. Okay, so 4 would be multiplied by 50. 5 would be multiplied by 50. 9 will be multiplied by 50. And 12 will be multiplied by 50. So here we'll have 200. 4 people can go for $200. 5 people will go for 250. 9 people for 450. And 12 people will go for 600. Okay, so yeah, I wouldn't, that's a lot of money. Display the relationship on the graph below. Okay, so here we have our X and Y, and I'm trying to make it so you can see the table and the graph. X is the number of people. We can see it in our equation and on the table. X is the number of people, and Y is the cost. Always label your X's to make sure that you understand and that I understand what you're working on. Okay, so in this case, probably will be easier if I count by 50. And let's do every 2, maybe I will make 50. So here I have 0, 50, 100, 150. So I'm making every 2 squares a 50. So every square will be $25. So 200, 250, 300, 350, 400, 450, 500, 550, and 600. Okay, and the number of people, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We don't need more than that. Oh no, we do. 11, 12. Okay, so now we need to graph that. So one person pays $50. 4 people pay 200. So 4, 200 right here. 5 people pay 250. 9 people will pay 450. And 12 people will pay 600. I can go ahead and connect these dots using my ruler. And here is the ruler. And see if I have the straight lines that goes through the origin to prove again that this is a proportional relationship. So here we answered the question. We have the constant unit rate or the constant of proportionality, $50 per person, and we have a straight line that goes through the origin on the graph. So we are going back to our question here. Is the cost of admission proportional to the amount of people? Yes, it is proportional because there is a constant of proportionality. There is a constant of proportionality. $50, and that means $50 per person. Okay. Also, if you were to describe it using a graph, it's a straight line that comes from the origin. What points must be on the graph of the line if their two quantities represented are proportional to each other? Explain why and describe these points in the context of the situation. So one thing that we continue talking about is that on the line has to go through the origin. So that means the point 0, 0 has to be on the graph. Okay, so the point 0, 0, and another point that has to be on the graph is the unit rate, because without it, our graph is going to be all different. Um, so we have to have a unit rate, which is, in this situation, 150. Origin and the unit rate. Okay. Um, Explain why and describe these points in the context of the situation. So no people can enter with no money, right? 0. No people can enter with no money, and each person has to pay $50. Okay. Would the point 7,350 be on this graph? Explain. Okay, so how can I see whether or not this point is on the graph? Well, I can look at the point on the graph and see that here I have 7 and 350. So yes, I can see it right away, but again, I cannot trust my eyes in math and I need to prove it. So 7 is my x and 350 is the y. To find the constant of proportionality, I would divide 350 by 7 and I will get 50. See, I found my unit rate all over again. That means I have the same unit rate. That means that 350 is on the graph. Yes, because the unit rate is still 50. Okay, that is all for lesson 10. I know it was long. I hope you understood it. And if you didn't, please make sure you message me and I will explain it to you again. I will see you in class.